find the limit if it exists, and we're looking at the limit as x approaches infinity of x squared all over the square root of x to the fourth plus 1. Now here we want to divide by the highest power of x in the denominator, and that's going to be an x to the fourth inside a square root. And the way that we divide by that is we divide the top and bottom by x squared. The reason we do that is that x squared on its own is the same as x to the fourth inside a square root. So this is going to be x squared over x squared. And then in the denominator, if we divide by x squared, that's the same as dividing by x to the fourth inside the radical. And so we end up getting the limit as x approaches infinity of 1 over the square root of 1 plus 1 over x to the fourth. Now we can split this up. The limit of a quotient is the quotient of the limits. So we can split this limit up into the top and bottom. And then the limit in the denominator we can pull inside the square root. And then we can split it up into these two terms separately. And so if we go ahead and apply all of those laws, we end up with the limit as x approaches infinity of 1 over the square root of the limit as x approaches infinity of 1 plus the limit as x approaches infinity of 1 over x to the fourth. Evaluating these limits give us 1 over the square root of 1 plus 0, because the limit of a constant is just that constant, and then the limit of 1 over x to the fourth as x approaches infinity is 0. So this becomes 1 over the square root of 1, which is 1 over 1, which is just 1. So that limit exists. In fact, it is equal to 1. And if we were to graph that function, we would have a horizontal asymptote at y equals 1.